better than I do on that.
All right. Well, let's talk, because we have some pictures here to get some ideas of exactly what we're talking about. And Joseph, I'm going to hold this up and just explain to me what it is we're looking at here.
Well, this is a linear electronic circuit, and basically this type of a device is used in aircraft, medical application, as well as the consumer application, depending on its end objective. Now, the problem here is that this device will come into our laboratory and will be, tested functionally and parametrically in accordance with the Philips specification, and it'll work. But as we see over here on the logo, this is not an authentic Philips logo.
I was just going to say, is this a real one or not?
It is not. It's a cloned unit that actually works in application, and the question herein lies, how long is it going to work for?
Correct. The other question, how can you tell it's a clone? Is it because they didn't spell the word Philips out all the way?
Well, it's one of the methodologies used. It's a no-brainer simply because you see a logo that doesn't look authentic,
right,
and generally that raises a red flag at the get-go.
Okay.
Yeah.
So whoever did it didn't do a very good job.
No, not at all.
All right. So that one you would spot. All right. What are we seeing here?
Well, over here we have the whole concept here is, here's a suspect Philips marking, okay? On the left side, we have a military unit with what is an authentic Philips logo, and it's a memory device that works in a circuit. And over here, we have a different type of memory device with a suspect Philips marking. And over here, unlike the original, you have a P with 5 dashes. And I don't know what this is over here, but it's a probable Philips logo. And the problem here is that this unit works electrically. And again, it goes back to, herein lies, how long will it work for?
That's the big question. So when something like this comes to your lab and you test it, I mean, you could look at that and say it's a counterfeit.
Absolutely.
So what do you do? What is your goal at that point? You already know it's counterfeit.
Right. Well, first of all, you obviously have to notify the customer immediately that you have a suspect unit over here. Unfortunately, in America and in Europe, the thinking here is, well, if it works electrically, it obviously must be an authentic unit. And we're starting to educate the industry more and more today. And what has happened is that after we developed this system, the largest online brokerage forum in the world, which is called the Broker Forum out of Montreal, Quebec, embraced our program and started educating customers all over the world to say, just because a device works electrically doesn't mean that it's an authentic unit. So that's been a big push in our industry. But the photos that we have here today clearly illustrate, without testing, the suspect units that are out there, and we're talking billions of electronic product.
Tell me a little bit about this. What are we looking at here?
Well, over here we have, again, another linear device, okay, with a memory inside of it.
These computer chips, silicon chips?
Yes,
that's what this is.
Most definitely are.
Okay.
And again, we have product that if we put them inside our testers, they work electrically. But here we could see that the ink marking just rubs off like butter, and that shouldn't be the case. So there again, a red flag goes up to say, we've got cloned product over here.
How long is that another thing that you have to worry about? It may work when you initially start using it. How long will these things work? Is that the big question?
That is the big question. It's very hard to say. So we've developed a program to just identify the cloned or the counterfeit, which really, when you think about it, it's the same thing. Is to identify it, bring it to the customer's attention, and reject it, disposition it as a reject right from the get-go.
Okay. Here's another picture. While we have this up, what are we looking at?
Well, at the very top, another thing that we've noticed coming out of China is that we have a lattice device over here, and in layman's terms, this device has a specific memory function, and what they did was they found out that the chip inside can perform, if you could see that there is another part marking underneath. Well, what they've done is they've taken the privilege to remark it with another part number, which is illegal and it's fraud. And many Americans and many European distributors are buying this product not knowing what they're getting themselves into.
If you can't notice it right on from the printing and things like that, how do you go about detecting counterfeit electronic parts, components?
What we have is a 3-level objective. And the quickest way is exactly what you're showing the viewers today. Suspect marking. You're looking at parts that are remarked. Right. You're looking at logos that are not authentic. So that's very easy to tell that, you know what, we may have a problem here. But there are chips out there that look pristine. Their physical dimensions are accurate as the manufacturers have them. Their leads are perfect in good shape. And then you go to test it electrically and it works. So you have tens of thousands of distributors and then end customers and the important customers that we were talking about, and they think that they have an authentic unit. So I've developed a system where I will dissect one of these components. I will open them up and I will do a 3-point inspection metallurgically to look at what are the elements. And for example, if one of these units over here were comprised of 3 elements, let's say 50% silicon, 25% aluminum, and 25% sulfur. Here it's very, very simple. You're looking at a spectra, and what I put together, part of this process, was a concept called X-ray diffraction and infrared spectroscopy. And by this methodology, we're able to go into the device and say, it's really simple. We found this much bromine, this much silicon, this much chlorine. And if the probable suspect unit does not have the same peak, if it does not look like that, you have a cloned unit, and therefore we would disposition it as a failure.
That's pretty amazing. You also were talking about how products come sometimes, this is a pretty interesting picture, I think it's the right side, packaged very sloppily,
Yeah.
which kind of gives you a clue that this is not good.
Right. Right. Well, what we see over here are components that are coming from the Shenzhen region of Guangdong province, China. And the Chinese people really do not know the dynamics of these components. They know nothing about the logos. They know nothing about the date codes. They don't even know what the device does. They're basically searching for component product and giving Americans and Europeans and major brokers all over the world what they're looking for. And when they're packaged in just any ordinary box. And over here you have an example of styrofoam, which is an electrostatic discharge hazard. These components could be destroyed right at the packaging. And what electrostatic discharge is, Doug, is if you walk on a carpet and you tap somebody's nose and you get that little discharge shock, that can ruin a component. But they don't know that, okay? And unfortunately, it comes into this country, it may go through a distributor or a broker, they may take that product and then put it in the proper packaging, and then the end customer didn't know where it really came from, and if it, if it was subjected to any type of hazard whatsoever.